Okay, thank you. Welcome everyone. This is going to be the last of the live sessions for this year's course. I think in the previous live sessions, there were some suggestions that we could do some courses in somewhat advanced part of number theory. So it is likely that I may take a course on somewhat higher aspects of number theory. It could be, yeah, I'll have to see. Maybe I will announce it, and meaning, I'll have to start recording for those lectures sometime in the coming semester. And then after a year, so perhaps from July 2024, this advanced course may start running, but we will see what we need to do. So thank you. Namaste, Bihari ji. It's good to see that people are logging in. So what we will do is that, in the last 15 minutes or so, we will thank you, Tejasvi. Good afternoon to you. So in the last 15 minutes or so, or 10 minutes or so, we will talk about the exam pattern. I know that many of you are going to be interested in how the exam pattern will be, what will be the final pattern of the examination. So I will talk about it in the last 10 to 15 minutes. So if there are any questions until then, please hang on. And, meaning it would help to talk about it in the last 15 minutes or so that everyone can get to hear about it. So if there are any questions, I will be very much interested in listening to those questions. Meanwhile, because there are no questions yet, I will maybe talk about this convergence business. So computing convergence is something which is not a difficult thing, meaning, people seem to think that computing a convergent to a real number is a difficult thing, but that is not so. Let me try to explain very briefly the method to compute the continued fraction algorithm expansion. So suppose, we have something like root 17, and root 17 we know lies between 4 and 5, because 17 lies between 16 and 25. And so therefore root 17 lies between root 16 and root 25. So when you compute the integral part of root 17, it will have to be 4. So we know that the first number in the continued fraction expansion has to be 4. Okay. So once that is taken care of, what you need to do is to look at the remaining part, which is the fractional part. You have for any real number, there is an integral part, which can be positive or negative. And then there is the fractional part. So here we are beginning with the root 17 as the positive square root of 17. Okay, not the negative one. That would have a different continued fraction algorithm. So Indumati, good afternoon to you also. Thank you very much. Yeah, so root 17 minus 4. That's the part we are looking at. We need to write this root 17 minus 4 as 1 upon something. So it's 1 upon root 17 minus 4. So that's the thing that we look at. And 1 upon root 17 minus 4 can be rationalized by multiplying by the number which is 1, which is root 17 plus 4 upon root 17 minus 4. And we get root 17 plus 4 upon 17 minus 4 square, which is 16. So we get just root 17 plus 4. Okay, so once again, root 17 is equal to 4 plus 1 upon root 17 plus 4. Now we have observed that root 17 ka integral part is 4. And therefore root 17 plus 4, the integral part will become 8. Correct? Because you have added 4 to it. So you now need to write it as root 17 plus 4, which is in the denominator, will be written as 8 plus root 17 plus 4 minus 8, which will become root 17 minus 4. And that root 17 minus 4 is again our fractional part. And so it will become 1 upon root 17 plus 4, which will continue to be 8 plus root 17 minus 4 and so on. So 8 is the what are called those those numbers AI that we are going to get. And therefore the partial fractions will look like, meaning the continued fraction expansion will look like 4, 8, 8, 8, 8, 8, 8, 8. That's how the continued fraction expansion looks like. So for numbers which are rationals or for numbers which are square roots of integers, it should not be difficult to compute it. if you're willing to put in some efforts, meaning some time before, when you don't have practice, you will have to write down with some, take pen and paper and sit down and do the dirty work of doing all the computations once. Once you do it, then you will have practice and then you will get better at it. Okay, so Indumati has a good question. Is there only 53 universal quadratic forms? This number escapes me. I don't remember now whether it is 53, but I may have told in my lecture that there is a paper by the Fields medalist Manjul Bhargav, and if you search for Manjul Bhargav quadratic forms, then you will be led by internet to a PDF file where this paper is available. And there in that paper, you can see Manjul's paper is very well written and the whole thing is very interesting. But Bihari says, please repeat this again. So by this, I hope he means root 17. Yeah. Okay. So root 17, what we observe is we are going to look at, first of all, the positive square root of 17. Okay. So this is a number which is bigger than 0. We are not looking at the negative of the number whose the negative number whose square is 17. All right. So this root 17 is between root 16 and root 25, because 17 is between 16 and 25. And we are looking at positive square roots anyway. So this is between 4 and 5. So the decimal expansion of root 17 will be 4 point some numbers. So if you were to take the integral part of root 17, it will be 4. And then the fractional part will be root 17 minus 4, whatever this number is, root 17. So you write it in a bracket, root 17 minus 4. Now you want to write this root 17 minus 4 as 1 upon x. So x has to be 1 upon root 17 minus 4. Correct? Now this 1 upon root 17 minus 4 will be multiplied by root 17 plus 4 upon root 17 plus 4. I am just multiplying it by 1. But the 1 is being written as root 17 plus 4 in the denominator, root 17 plus 4 in the numerator. This is the process of clearing the denominators, writing it in the better form. So 1 upon root 17 minus 4 is root 17 plus 4 in the numerator divided by root 17 square minus 4 square. Root 17 square is 17, 4 square is 16. So 17 minus 16 is 1. So we have computed 1 upon root 17 minus 4 to be root 17 plus 4. So we have our original number root 17 equal to 4 plus bracket root 17 minus 4, which is equal to 4 plus 1 upon root 17 plus 4, because now root 17 minus 4 is the reciprocal of root 17 plus 4. Okay, so now we have written our theta as a0 plus 1 upon x1. x1 is root 17 plus 4. And the integral part of root 17 plus 4 is the integral part of root 17 plus 4. Therefore, the integral part of this x1 is 8. Okay. So you will write root 17 as 4 plus 1 upon and draw a long enough horizontal line. Below the horizontal line, you will write 8 plus the fractional part. But the fractional part is root 17 plus 4 minus 8. The number is root 17 plus 4 and you have to subtract the integral part. So what you get in the bracket is in fact again going to give you root 17 minus 4. And this is the calculation you have done earlier. This is 1 upon root 17 plus 4, which will again give you 8 as the integral part, and this process continues. And therefore, we get it to be 4, then the semicolon, and then 8, 8, 8, 8, 8. This is the way the continued fraction expansion for quadratic irrationals can be computed. If there are rational numbers thrown in with this, then it's not a difficult thing. Again, the computation will be slightly complicated, but this is the way this is to be done. Yeah. So I also wrote an email maybe 10-15 minutes back that every convergent will be a good approximation, but every good approximation need not be a convergent. In fact, to be a convergent, the good approximation has to be slightly better. So the number 301 upon 73 is a good approximation. And so unfortunately, we will have to reevaluate that assignment. That aside, the main point here is that although some number may be good approximation, it may not still be a convergent to the given real number theta. Okay, good. So let me take a look at some of the questions. Here is a very interesting question. How to get into an IIT and what's your story being an IIT professor? So I won't tell it so easily. This is not a story that you will get to know for free. I think you should come to my office and maybe over a coffee we can discuss it. So having said that, of course, if any of you is going to be in IIT Bombay, I think it will be a nice thing to just see each other. If you are going to be here, do drop me an email and I'll find out some time and we can hang around and chat for a while. Job opportunity in pharmacy. I think this is the wrong question, asked in the wrong part. Okay. So someone has asked, find three smallest non-zero values represented by the given form. So I think this is something which we have done already in the course. So I would not go over this whole thing once again, but the basic thing is that suppose you have a reduced form. Okay, suppose you have a reduced form, which means that the coefficients have some inequality condition. If that happens, then A is one of the numbers which is represented by your form, which is given by putting x equal to 1 and y equal to 0. Okay. Similarly, C, the coefficient of y square, that's again another number represented by your form, which is given by 0, 1. So you put y equal to 1 and x equal to 0. And then you can put x equal to 1, y equal to 1 or plus minus 1. So, you can put x equal to 1, y equal to 1 or x equal to 1, y equal to minus 1. In both cases, you will get A plus C plus minus B. So those are the numbers which are again represented by the forms. And in many cases, these happen to be the smallest non-zero numbers represented by your form. If these happen, if there is a coincidence among these numbers, for instance, your A happens to be C, so then you don't get three distinct numbers. Okay, in that case, you will have to compute some more. You will have to compute, for numbers which are obtained by putting x equal to 1, y equal to 2, or x equal to 2, y equal to 1. Those are the things that you will have to do. Another thing to do is to, get some values represented by your number, represented by your form, and check for all the smaller numbers which are represented by your form. Okay, so once you have that, given a number and given a form, it's not a very, meaning if the numbers are reasonably small, it's not a very big deal to check whether the number is represented by the form or not. Because, the A is given to you, C is given to you, B is given to you. So you know how the form looks like, how the numbers look like. And clearly, beyond some numbers, if the Y is very large, then you know that the numbers are going to be very big. So you will be forced to take some small values of X and small values of Y. And that will, make your number of cases to be a finite number. So it should not be very difficult to check. Once you are given a form and the number. So here in this case, the form is supposed to be given by 5, minus 3 and 7. So of course, 5 and 7 are going to be represented by the form. And then you have to add 7 and 5, which gives you 12. And you subtract 3 from that. So you get 9. So that is one number. You can add 3 to it, but that will give you a bigger number. So for this given form, 5x square minus 3xy plus 7y square, 5, 7, and 9 seem to be the smallest non-zero numbers represented by the form. So this is, of course, using the theorem that we have done in the class, which is that given a reduced form, the smallest three non-zero numbers can be given by the coefficients A, B, C. But if there is a coincidence among them, then you'll have to go a little beyond them and do some mathematical computation. This was asked by Gayatri, so I hope this is an answer. Correct. So this was a question. Okay, so let me mention the question that has been given here again. This is asked by Arindam Chakraborty, who says that the provided solution shows the option which is provided in the answers anyway, and therefore that may not really be very useful, because that is just the same as telling what is the correct answer. So little more detail are given for the previous year's assignment. So I have given in the same tab where you look for assignment, solutions, etc., or even the lectures. There below you will see detailed solutions, and please let me know by email if you do not find it in the same tab. So these are the detailed solutions for the previous year's question papers, for the previous year's assignments. So the numbers are different. The assignments this time are different, but the types of the assignments are the same. For instance, in the previous year's assignment, I may have asked for computing primes which are giving the Legendre symbol 30 by p equal to 1. Here I may ask for 24 by p equal to 1. So those kind of differences may be there, but then it would tell you that you write 30 as a product of prime numbers, 2 into 3 into 5. You will have to write it as 2 by p, the Legendre symbol 2 by p, 3 by p, and 5 by p. If you want this equal to be 1, what you should have is that either all are 1 or exactly 2 are minus 1 and the third one is 1, which gives you some kind of congruence conditions, different sets of congruence conditions, and for each set of congruence conditions, supposing 2 by p is 1, 3 by p is minus 1, 5 by p is minus 1. So these give you 3 congruence conditions modulo different numbers. For 2, it would be perhaps modulo 8. And then you will use the Chinese remainder theorem to find the final condition, congruence condition that you will get. Okay, so using them, it would be possible to check the given options. Of course, another option is you are given the list of primes. You should first check whether p is a prime. The given numbers, they are primes. And once you have checked that they are primes, you can just compute. Suppose you are given the number to be whatever, I don't know. So maybe 2023, is that a prime? That may not be a prime. So what could be a good prime? 127. Okay, so if you look at 24 upon 127, you want to compute this Legendre symbol, whether this is 1 or not, you will need to use of course, you will use 2 upon 127 because 24 is 8 into 3. 8 is 4 into 2. The 4 you can ignore. So it is really 2 upon 127 and 3 upon 127. So 2 upon 127 should be easy because, you know, this is just congruence condition modulo 8 for 2. So this is minus 1 modulo 8, and therefore I think 2 is a square modulo that. So you need to check whether 3 modulo 127, that gives you the Legendre symbol equal to 1. And that can be obtained by using the reciprocity, quadratic reciprocity law. So it is 127 upon 3, and both are congruent to minus 1. So you will have to put a minus. Both are congruent to 3 mod 4. So you'll have to put a minus sign outside and check whether 127 modulo 3 is a 1, but that is indeed a 1, and therefore because you have a minus sign, you will have that 24 modulo 127 is not a quadratic residue. So those are the kind of things that one will have to do to find the final solution. But writing all these things is, you know, it is merely repeating what I have done in my lectures for different solutions. So if I have to just give you the brief reasoning, then that brief reasoning is already given in previous year's assignments, and those have been made available. So you have a different set of assignments in addition to the assignments that are there for this year. So for practice, you have double the set of problems as you would have for this year's assignment. So you have double the set of problems with some details of the solutions, and giving more details than them is not practically possible. It takes long time to write down all these things. And running this course is being done with all other things being done. So I'm sorry, we cannot do anything more than that. There is one more question asked by Arindam. Let me see. So Arindam says in assignment questions, there are more. Oh no, that is Shubhashri's question, but Arindam has one more thing. Yeah. Okay, I guess I may require some help. Yeah. Some of the questions are too time consuming and sometimes very difficult to sort without computer programming. Will the questions in the final test be like this only? I don't believe this. I don't believe that I am myself a particularly good person to do computations, meaning I make many mistakes and I'm not one who does a lot of computations. But in a course like basic number theory, if there are if I give you 10 problems, each problem will have say 6 options, and you are expected to do this in a week or 10 days, say. So per problem, it should not take you more than 10 to 15 minutes. 10 to 15 minutes is the max. And typically what would happen is that there are 2 problems for each type. So once you solve a problem of a given type, solving the next problem of a similar type should become slightly easier. This is my very strong feeling. And therefore, if something cannot be done without computer programming, that will be very difficult to see. I think, what I could... to tell you, we have been teaching this course in IIT Bombay regularly, and there we solve these problems on board for students. So we don't use any kind of computer programming. Some calculators may be needed, but I believe that the NPTEL computers are provided with calculators. So you will have calculators at your disposal, but computer program will of course not be there. And since I don't believe that there are, of course, some questions may be time consuming. So what happens is that sometimes, you may get astray. When you're solving a problem, you may get in a different direction, and that may feel like it's too time consuming. But meaning if you're using the correct method, if you're listening to all the lectures, then it should not be the case that you need computer programming to solve the problems, and it's not possible without that. I'm sorry, but I don't believe that. So of course, since those questions are not there in the assignments, those questions will also not be there in the final exam. Okay. Yeah, so maybe I could take some questions which are asked here, and I could go back to the questions which are there in the Excel sheet later. So Kapil is asking, sir, what will be the final exam pattern? Will question be in multiple correct form with 6 options? I think it would be tempting to go with such kind of things. Okay, Gopika says that the previous year's assignment answers are not available. I will see to it that they are made available. What happens is that I also have an account with a different email ID, and therefore I can also check what is there. So I think they are available, but I will check it once again. Once again, there is a question by Radharani Bhakta. Good afternoon, sir. What will be the final question paper pattern? Will it be MSQ type or written solution? Will we have to submit? So first of all, meaning I'm very happy to inform you that there are about 7,000 people who have registered for this. This was when I checked some time back. Now the number may hopefully have increased and not decreased. So even if we say that 10% of the people register for exam, it will be 700 people who will register for exam, and that will be a lot of people who will be writing the question paper answers, and so it will be a difficult time to grade. So clearly there will be no long answers that are expected. Okay, but the question paper pattern will be somewhat so that you will have to put in some numbers, and then those answers can be machine graded. Those are the things that I will be looking at. So Kapil and Radharani, hang on. I will be giving out some details about the final exam paper pattern. I just want to wait until everybody is here, meaning, right now we are roughly halfway through of our live session. So when we are in the last 15 minutes or so, then I will spend some time. Last year's detailed solutions. So Suresh sir, once again, the details can only be given to some extent, meaning some people have been actually very enterprising and very cooperative. They have submitted their whole solutions after the assignment answers have been announced. Some people have shared their whole solutions. I don't know if people have appreciated that. I have seen it happening at least twice, and in discussion forum, nobody has even said a thank you to them. So there are some people who have shared their whole worked out solutions, and nobody has even acknowledged that. So those are the detailed solutions that you should be looking at. And so if you are looking for them, you should at least appreciate that, so that those people continue to do it for all the remaining assignments, or even the previous assignments. They may have some of these. I think, it was submitted for assignment 7 or assignment 9 or assignment 6. At least for 2 of the assignments, the detailed solutions have been submitted by some learner, and nobody has appreciated that. So please check all these emails in the discussion forum and do write back to them, ask them for the remaining assignment solutions, and they will be happy to share. Yeah. So Kapil's thing about 6 questions, I don't know, 6 options, maybe one should think about it. Whenever my students in the classes usually ask me whether this type of questions will be there in the final exam, I always get tempted to put in those kind of questions. But I will think, don't worry. All right, so since there are... Okay, so in the Excel sheet, these are the only questions. I think other than the questions which are, there is one question about the quadratic form and 3 smallest non-zero values. I think I have answered that. This Arindam has some valid points about the questions, but I do not agree with one of his points. Subhashri has something about assignment questions. So, yeah, so this is again deals with the final exam pattern, and I have promised to talk about it in, say, 15 more minutes or so. But until then, I'll be happy to take some more questions. So I think, meaning, we may be in the 11th week now, and there is just one more week remaining. So you will have time to see the remaining 5 or 6 lectures also, starting this Friday in a day or two. So if there are any questions, I will be happy to take those. Otherwise, I keep talking. Drink some water. So I have explained in the beginning of this video. If you joined a bit late, then I have explained how to find the continued fraction expansion of some quadratic rationals. I think those are the things that you may want to look back when when our session is complete, and this will be available on YouTube as a video, and then you can go back and see what I have talked about it in the beginning, and you will see the the continued fraction expansion of square root 17. So that will tell you how to find the continued fraction expansion for quadratic irrationals. Okay, so continued fraction expansion is something that you may have. It's a very beautiful thing. and it leads to many important properties. There are these convergence which give you good approximations. In fact, they are the better approximations in the sense, and in some sense, these are the best approximations. So there is also a lecture which I have given sometime 2-3 years back. It may be available on my YouTube channel. So if you search for Shripad Garge and YouTube channel, you may be um, led to this. If you don't find it, send an email to my email address or put an email on the discussion forum, and I will share that lecture. So it's a separate lecture where I have described what are continued fraction expansions, what is a better approximation, and I have also explained how to get the best approximation in some sense. So I may also tell you that, the continued fraction expansions have been somewhat generalized, meaning here we look at only real numbers and we try to get the continued fraction expansion in terms of integers. It is possible to look at complex numbers and ask whether it's possible to look at complex numbers and ask whether you have a set which is slightly bigger than integers, which will give you some kind of a continued fraction expansion for complex number. And that has been done by many people, where you replace your integers by what are called Gaussian integers. So there are again many options. Once you go to complex numbers, the integers can be generalized in several ways. And so there are several options, and all those options have been explored, and a very beautiful theory exists for continued fraction expansions of complex numbers. So Suresh K has said previous year detailed assignment solutions. Indeed, so those are the things I was talking about. So those will be, meaning, if you look at the solutions, after every set of 2 or 3 problems, there will be some small brief detail that has been given. And those are the things by which I mean the details. So I also made it clear that we cannot write every detail for every solution. That will be very difficult to write. It will first of all take too much time. And the more time we take to write these things, we tend to make more mistakes. Meaning, making computations on a board or making computations on pen and paper is a different thing. But when you are typing it, there is the LaTeXing which is involved in it, and the numbers are involved. So, when you are typing it, there are some human errors which creep in. So that's why writing full details is not advisable anyway, because those are the things that you are supposed to do. But the main steps are given in those detailed solutions. So previous year in 2020, when I ran this course, I was asked for some details, and when I provided those brief details, people seemed happy that time. So I think that is something which may work. Bihari Mathematics has, sir, there are a lot of things you only speak. If possible, please write it on lecture slides. So, these live interaction session are not supposed to be lectures. So we are, meaning I don't have a lecture slide here, and I particularly did not request for it. So if I had requested, I'm sure our people would have provided me, but I did not request for it because this is supposed to be a chit chat session. This is supposed to be a session where we express our ideas, where you ask me some questions on which I can just speak. This is important. Sometimes, you just listen to it and learn by that. Not everything can be written down. That is important also. So maybe I'm giving too many pandas this time rather than giving any important information. But, for instance, this continued fraction expansion of root 17, I think, just speaking it also makes some sense instead of writing it down. Right? So not everything can be written down on lecture slides. I would, meaning, given the opportunity, I would like to take as many lectures as possible. But the idea behind live interaction session is not that, I give you another lecture. I have already given 60 or 61 lectures. This will not be 62, 63, 64. This has to be something different. And here we talk about things. So this is important. Okay, and we still have maybe 10 minutes. If you can keep me engaged for 10 minutes, then after that, I promise to tell you about the final exam paper pattern. You could, okay, he was talking about course lectures. Yeah, so in the course lectures also, you think I should have written down, okay. Then maybe for the other courses that I give, I will keep that in mind. Yeah, thank you. Um, Sanjeev Kumar Jaiswal says, sir, how can we find D? Do you mean to say you? Is that the Shakespeare English that you're using here? So Indumati is asking, can I use a calculator for the examination? I believe it is possible. Meaning you will be provided a computer when you write your final examination, and I believe that a calculator is inbuilt in the computer. But to make sure, you can ask. You can just ask. You can write to NPTEL and ask them whether a calculator will be there inbuilt in the system. You will, of course, not be allowed to use your own calculator, scientific or otherwise. Whatever calculator you bring, perhaps a pen and paper so that you can do some of these things, calculations yourself, may be allowed, or that may be already be provided by NPTEL. NPTEL may themselves give you blank papers and some pens, but it's good to bring your own pen. It's good to bring your own empty sheets of papers. It's good to bring your own water bottle and water, mask, anything else that you may think is important. And then, you can do those things. So I'm happy to see that many people are asking about final exam paper. That means you have registered for these final exams. I'm very happy to see that. And once again, I repeat my invitation that, if you happen to come to IIT Bombay anytime, it will be a pleasure to see you. Just drop me an email. And finding my email is not a difficult thing. I think you write my email address, write my name, IIT Bombay on Google, and you will be able to find my email ID. Okay, maybe there are 10-15 minutes which are remaining now, in which I could discuss the pattern for the final examination. Yes, so here it comes. So once again, there may be an NPTEL policy to announce this. So I'm not going to give all the details. I will request NPTEL to announce it on their own behalf. But what we will have in the following is that, of course, there will be some questions which are of the type true or false. So given a sentence, you will have to choose whether it's true or false. There will be no explanation required. You will need to choose one of the two options, true or false, and that's it. Those are questions for 1 mark. So either it will be true or false, or it will be finite, infinite, or it will be 0 and 2. Some options will be given, and you will have to choose from those options. They may be 6, they may be 2, they may be 3. Multiple answers may be correct. You will have to choose all the correct options. These are the questions which are the multiple types. Then there are some another questions, 5 in all. So the first type of questions, there are 10 such things, 1 mark each. So you have 10 marks there. Second type, you will have some questions which will require a little more calculation than what you had to do in the first part. Here, each question is for 2 marks, and you are supposed to enter the final answer. Here, you are not given the options. Once you are given options, typically it is simpler to get to the correct answers from the given options. But when you have to compute the answer, then you have to get down to it and write the final answer. Okay, so there are 5 such questions worth 2 marks each. Okay, so there are 5 questions worth 2 marks each. This is in the second type, that counts for 10 more marks. 10 questions of 1 mark, 5 questions of 2 marks. Those are total 20 marks. And then there are 3 long questions for 10 marks each. The aim of each of those 3 questions would be to arrive at an answer of a long question. And so there are some steps which will be required in doing those computations. And I will ask you to give me the answers to some of those integers involved in those steps. So there will be marks which will be distributed in those steps. And I will ask you to give me the number which you get by doing this, and that will be the answer for that particular sub question. So each sub question can have marks 2, half, 1, depending on the number of calculations that you have to do for that sub question. Okay, so 10 questions for 1 mark each, 5 questions for 2 marks each, and 3 questions for 10 marks each. That is the final exam paper pattern. You will be required to do a lot of calculations yourself. You will be required to remember some of the formulas, some of the important things that we have done in the course. And that's it. I think that is the thing that you will have to learn to do this. So Vipin Kohli, thank you for showing up. Something about Ramanujan universal form. So I don't know what is the Ramanujan universal form. In fact, Ramanujan had given a list of some binary quadratic forms which he claimed were not binary. He had given some list of quadratic forms and he claimed that they were universal, and Manjul Bhargava worked on it. This is some story which I have repeated, which I have already said in my lectures. So that is something I will not be able to say. So there is no one single Ramanujan universal form as far as I know. Of course, there is the form of Lagrange, which is x square plus y square plus z square plus w square. That's the form due to Lagrange. Okay, so there you go. I have told the pattern for the final examination of this course. And this course may run once again not in the next year, but the year after that. And if everything goes well, then in the next year, we may have an advanced course on number theory, slightly advanced, not very advanced, but a slightly advanced course on number theory running, which may again be for 12 weeks or it may be for 8 weeks. If everything goes well, meaning I will have to submit a proposal for that, then I'll have to start recording the lectures and prepare the assignments and so on. And then everything is done in time, we will have the course ready. So that is about it. I think we have 10-15 minutes more. There were no other questions which have been asked. There was one question asked by Omveer Singh, who has, this is not a mathematical question, but so I did not take it in the beginning discussion, but I will now talk about it. He says he's from a tier 3 college. So what's the advantage of doing this course in different places, such as placement, internship, etc.? So typically, when you do one particular thing, it is not easy to quantify the applications or the benefit of doing that one particular thing. What will happen is that you may do a few things together. You may attend this course, you may do something else and something else. And then you will perhaps see benefit of doing all these things together in one place. So, meaning doing mathematics or doing these kind of courses also improves your analytical thinking. It improves your calculation prowess. It improves the way you think about various things. So other than that, there are no advantages, meaning these are some of the natural advantages of doing mathematics courses. But other than this, there may not be advantage in the different places such as placement and internship. You may, of course, say that you have done such a course from a professor in IIT Bombay, an NPTEL course, and this is your score, and that will be impressive. But if your job requirement is such that some number theory or some analytical thinking is required, then it will be good. Otherwise, it can be taken as an extra credit, something that you have been able to do. So that is already there. So Kapil Jain is asking whether there is a partial credit to a question. So, meaning the first 10 questions, which are for 1 mark each, where there may be options and you are asked to choose some correct option, but those are again typically not very time consuming questions. But other than that, there are the questions where you are required to write the final answer. In that, there cannot be a partial credit, meaning you are supposed to write one answer. To give you an example of a very basic question would be, what is the square of 10? If this is a question and there is this answer which is for 2 marks, if you write 100, then you get 2 marks. And if you write anything else, you don't get anything. Okay, so those are the things that we will have. But if there is a long question, so there is, I told you that there are there is first part which will have 10 questions worth 1 mark. Second part where there are 5 questions worth 2 marks. And then there are third, fourth, fifth parts where there is a one big question which is broken down into several stages. If you give correct answers to some of the stages, you will get correct marks for those stages. But if you make a mistake, and so the other answers from then on, from your mistake onwards, are different, then you don't get marks. However, there is a drawback in this kind of grading, which is that you may make mistake and still arrive at the correct answer, and you will therefore get full marks. Well, Indumati says, thank you. You are welcome, Indumati. We will. Okay. Oh, Sanjit Kumar asking, how can we find the convergence of a given rational number? This should be very easy. Meaning what I have told you can be done very easily for a rational number. You have a rational number x and you write it as a0 plus 1 upon x1. Okay, this kind of, once you know what is x, finding the a0, which is your integral part, should not be a problem. It's just the largest integer, which is less than your number or equal to your number. Okay, and once you have found that integer, you take it there, you write x minus a0 and compute its reciprocal, that will be your x1, and then continue the process for x1. So those are the things that one can do by finding the convergence. So Vipin is happy that this course went by. Thank you, Vipin. Yeah, David Burton's book is a delight to read. Yes. So Radharani is asking whether I can discuss research areas related to number theory. I am afraid that now we don't have time, but maybe, maybe you can visit me in IIT Bombay sometime and we can discuss those things. Current research areas in number theory, or indeed, so, there is this millennium problems I talked about, and in millennium problems, there are several of the famous research areas. Indeed, there are many research areas, but, to talk about some of those research areas, it will need some time to develop the terms need to be introduced, the notations will have to be introduced. So even to explain those questions will take some time. Is there negative marking? No, there is no negative marking. If your answer is wrong, no problem. Go ahead, be adventurous. Once again, coming back to Radharani's question about current research areas, there is something called elliptic curve in algebraic geometry or in number theory, which is a very hot topic these days. There are modular forms, which are very important. It could be called a part of analytic number theory. There is something called as Iwasawa theory. I'm just throwing some words. I think, you can go to check some of these sites about which I may have told earlier and check these things. Then there is what is called inverse Galois theory. So Galois theory talks about whenever you are given a field extension, there is a Galois group which you can compute. And the question is whether every finite group comes as a Galois group, which is a very non-trivial question. And the study of this kind of question is called inverse Galois theory. So one Indian mathematician by name Chandrasekhar Khare has made some very good progress on this question in the last 5 years or so. So that is also another research area among the current research areas in number theory. Also I will say that sometimes as the areas get developed, they intertwine with other areas. So sometimes you may think that there is a problem in number theory, but to explain or to answer this problem in number theory, you may have to take help from algebraic geometry, topology, or even going as far as PDEs and so on. So, it gets very difficult. There are some surprising connections sometimes. So there are some articles which are written on this. I think the unreasonable effectiveness of mathematics. This is one particular article where you may find many such examples. So indeed, you may search for some. Once you are done with this exam, once you write the final exam and so on, then you could do some search on internet and find out. Okay, so among also about other questions which have been asked, the first question was how to get into an IIT. So I could maybe just spend 1 or 2 minutes on that before we stop this live session. So IITs have entrance exams for all levels. So meaning the typical thing is to enter here for BTech program. If you are not interested in entering for BTech program, would like to do somewhere some bachelor's and then come for master's, that is possible. You can write what is called a joint admission for masters. So this is called JAM. That clearing that examination will allow you to come here for the master's exam, master's program. Then there is the GATE examination, which is one of the more well-known examination among engineers other than the JEE. So GATE will allow you, as far as mathematics goes, to also come here with a fellowship. If you clear GATE, if your score is one of the top few scores and you clear our IIT Bombay entrance exam and the interview, then you will be selected for a PhD here with a fellowship. And these are some of the ways. And after that, of course, you could come here as a faculty member like I have done, but more on that in some another time, some another day. So I guess this is all that we have to discuss today. I hope you all do well in your final examination and please keep in touch. Of course, there are 2 more assignments. The solutions will be out and we may have discussions on those 2 assignments. So good luck to you all from my side. And thank you again for showing your interest in this course. Thank you and bye.